Unless like we catch up somehow, then you can.
All right. Good morning, everyone. Any questions? Yes.
Cody?
We have to do that super thing.
I'm sorry.
A super fast for that final.
Yes.
Oh,
That's exactly why I'm going through all of this stuff here in a mad rush. So there will be a couple of questions on inheritance on the final. A couple of questions, which is why I am spending this time going through the book instead of, frittering it away with a review session or something.
Who needs a review session?
Exactly. So there will be literally 2 questions on inheritance on the final. So something with super and subclasses, and something with invoking methods and having the figuring out which method gets called, that kind of stuff. Yeah.
I did a quick question for this class. Does this class start at 10:30 or at noon?
At 10:30.
Okay.
I have the same question that you have. Why?
No, you're in the wrong class.
No. Oh, I see. No. For the point. Okay. From the point of view of determining the final, it goes by noon. So let's make sure that everyone is there at the right. Yes. Excellent. So yeah. Let's.
Thursday. That's for sure.
Okay. Well, of course, I'm not on the internet. Let's make sure that everyone here agrees when our final is, because that would be awfully inconvenient if we didn't. Okay. Current students. Calendars and events. Final exams. So the final is on
9:45 on Thursday.
Exactly.
15.
Here. This one. Thursday, December 15th. Here. Okay, let's make sure that everyone is there. All right.
How long do we have? 12. Okay.
It's till 12. You have 2 hours and 15 minutes. It's 145 minutes.
You think it's going to take the entire time? Or?
It's going to be...
obviously.
Well, the way it always goes is that people put too much stuff in the final. And so you definitely want to read through the final first, and you want to figure out which of the questions you are likely to do well on, and do those first. As you have observed in the last 2 exams, it's really difficult to give partial credit when someone just has a completely wrong answer. And so you're much better off getting several things completely right than attempting everything. So if time is if you don't have enough time, do not try to put in a little bit in every question. I've seen with several people, they just got a bunch of zeros or ones because that was all the partial credit that one could give. So there's a definite premium in this class on getting things actually right. Yes, it's totally un-American. So yes, a mere attempt is not actually good enough, and it's just the way it is.
How many questions can we expect?
There's going to be either 7 or 8 questions. So exactly. So if there's 4 instructors, everyone is submitting 2 questions. If one of them turns out to be really crappy, we'll toss it out and end up at 7. 7 would actually be the same as we've had before. I've told people to make their questions easier, And they do seem to be a little bit. I don't think any one of the questions is incredibly hard. You should be able to eyeball the question, and you should know pretty much right away, can I do this or can't I? And when you to do those that you can first, and get them to completion. People asked, what should they do? And what you should do is practice, practice, practice. And so the easiest thing to practice is coding bath. Coding bath is always good to do some of the easier problems first until you feel confident that you can tackle some of the harder ones. I'll post a list of coding bath questions for you. I can show a sample final. I'll dig out an old one. I don't think it'll be incredibly helpful, but I mean, I'll do it. There's no harm.
You can still refer to like past homework and stuff.
Yes. So it's open laptop, open everything. You can load up your laptop with all of the old exams and homeworks and everything in solutions. You can look into Desire to Learn for what it's worth. You can try to Google the question on the internet, and if you find it, then we have failed. And so it's the same as everything. You don't have a lot of time for that kind of exploration, so it's always a good idea to have the material well organized and handy. The other thing that is really important is that since several of them are coding problems, that your fingers know how do you start up whatever your IDE is. If you are experienced and now you've seen the benefits of NetBeans, go ahead and use NetBeans. It does offer fancy features like auto-completion and these quick help things. If, on the other hand, you think that's not what you want to experiment with right now, stick with BlueJ. BlueJ will be just fine, but really be able to go to BlueJ, click, 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 make a new project, so that it's just like that. This time you will be getting the question text you can paste it in from the PDF like last time, or you can get it from a zip file. People were complaining that they didn't know how to paste, and none of this section. And so you have the choice of getting them either. So if you wanted to practice opening up a zip file really quickly, that might be helpful too. And otherwise, really just practice doing short programs. I mean, that's the most important thing that you can do. There's going to be a couple of code tracing questions. I don't think anyone has that particular difficulty with code tracing, but you might want to review a couple from the other exams. And you can always trace the bugs in your own code. All right, so let's go through inheritance so that we know which part we need to know. We're covering sections 10.1 to 10.3 only, and so we've gone through the basic thing here on how to set up a hierarchy, what goes in the superclass, what goes in the subclass. So now let's go to the next step and say, let's say someone forced us to implement a subclass. Someone said, here's the hierarchy, you should have a bank account, and then you should have a subclass that deals with savings. So in that case, you have to ask yourself, what data goes in the subclass? So in this case here, the interest rate goes into the subclass because every savings account has an interest rate, but a bank account doesn't. So it's specific to the subclass. And you declare it as a field just like you would with any other field. You just put it in here. Now, what about the balance? Where's the balance?
It's in a different class.
Yes, specifically in which?
Different class?
Yes. So the balance is here. So, and that's fine. And you just inherit the balance. You inherit all of the fields that you don't put in yourself. Now here's a common error that people make. People kind of forget about that inheritance part, and now they also put in another balance field in here. So let's say that one of your clueless friends did this by accident. Now what would happen?
Would it replace the method?
No, unfortunately, it's not a method, it's a field.
Or the field? Would it
It's
like replace it? Or?
No, it does not replace it. Yeah?
Well, if you're gonna call get balance for the savings account, it's gonna read that.
All right. Yeah, this is actually more subtle than I thought. So let me draw the picture. So from the super hateful thing. Let's do it again. From the superclass, we get a balance. In the subclass, we have an interest rate. And now, if we were foolish enough to declare balance again, we would get another instance field called balance. So we'd have two balances. And in the superclass, it uses this one here. So when you call get balance, which is a method of the superclass, it would read this one. And if the subclass, you would touch this balance with some other method, it would read that one. And the result would be a mess. Right? So don't do that. So be careful not to declare the variable again in the subclass. You will get another unrelated variable. Will the compiler warn you? No.
Syntax or
It won't give you a syntax error, it won't give you a warning. It'll just smile. So it's a common error to make, and you just need to be careful. Alright, so now let's move on to how would you implement methods in this situation. So here you can have the same picture. Here you see what's in the superclass, what's in the subclass. So let's do a method. So we'll do the add interest method. That's the only method that this class has, and I've chosen that one because it's pretty simple. So I'll compute the interest. So we have the interest rate, it's over here. So interest rate divided by 100 is then the percentage. And now I have to get at the balance. Now how do I get at the balance? The balance is a field of the bank account superclass. It's a private field of that superclass.
So you have to make it public. And
I can't do that. Because the idea is when you extend a class, you don't muck with the class that you extend. So making it public, it would work in this case because we happen to have control over that class, but many times you extend a class that doesn't belong to you, that's in some library, you don't even have the source code for it. So we can't make the field public, but we can do the next best thing. We can call a public method that reveals the field. So in this case here, we can call getBalance. GetBalance is a public method, and it gives me the balance. So it's important that you must call the public method to access the superclass. So the superclass fields are private. They're private to everyone, even to their descendants. Like if your parents have a private bank account, you don't have access to it any more than anyone else. You could call up the bank and say, well, it's my dad's account, and they aren't going to give you the time of day. And it's the same here. A private field in any class is private only to that class, so the bank account's balance cannot be touched by the public. But of course they can call getBalance, that's a public method. So you just need to remember to do that. So we call this public method getBalance, that gives us the balance. And now I figure out the interest, and now I need to add the interest to the balance. Again, I can't just say balance equals balance plus interest, because that's a private field. I have to use another public method. Fortunately, there is one, namely good old deposit. Note that when I call this method here, there's no dot. Normally when you call a method, you say some object dot method, thanks. And now here there's no dot. And that means that you call it on itself. So when you have a savings account, and here you call deposit, then that means deposit to myself. So when I add interest, I compute the interest by getting the balance of myself and then depositing it to myself. So if there's no dot, that means to yourself. And so you'll commonly find that when you make a method in a subclass, because the only way that you can interact with a part of yourself, with a private part of yourself, is through calling methods, you'll find these method calls without a doubt. All right, so that was adding the balance. So now we need to move on to one more twist, and then we're actually done. So now I want to go to the checking account, and in the checking account we have to implement two methods, with deposit and withdraw, that I'm going to move on to next. Alright, so let's go through deposit, and I'm going to do it a couple of wrong ways so that you see the subtlety. So the way deposit works is it increments the transaction count. And it does that so that eventually when in the charge fees method, when we have the transaction count over 5, then we can charge this fee. So we increment the transaction count, and now of course I still have to do the actual deposit. I was given an amount to deposit, and then I need to put it in. And so here I'm trying to do it the dumb way by saying balance equals balance plus amount. Why is it wrong?
You can just add it to the balance?
No, the math is right. That's how you would add the amount to the balance. But there's something wrong.
The bank account class is private?
The bank account class is a superclass, and what's private?
Balance.
Balance is private. Excellent. Balance is a private field of the superclass, and so you have to call some method on the bank account. So it's private. Because it's a field of the bank account. It's an instance variable of the bank account, and all instance variables are supposed to be private.
Wait, it won't tell you if there's
Oh, so in this case you will get an error.
Okay.
Yes. So in this case you'll get an error, and the error will be that it can't access balance. And so this is what students then do. They say, oh, it can't access balance. Then they look and they say, well, there isn't any balance. And then they add a balance. Then the error goes away. But then, of course, you have these two balance variables that don't talk to each other, and which is bad. So it's private, and so the remedy is not to make it public. The remedy is not to add another variable. The remedy is to call some method. Which method do we need to call? Yes.
Get
Okay, here we can call get balance, and that'll give us the balance. And how do we change the balance?
Deposit.
It is deposit, right? There is no set balance method in the bank account. Bank account says withdraw, deposit, and get balance. So we have to call deposit. That brings me to the next slide. Here it is. So yeah, we're computing the transaction count, and now we're just going to deposit the amount.
But doesn't it mean? But doesn't deposit without the dot mean it's just calling itself?
Aha! So.
Oh, so it's not calling.
So what you say is perfectly correct. So this means deposit to myself. Right. So now I need a deposit to myself.
What do you want?
So now the question is, which deposit method is it going to call? Because now we have an unfortunate situation. Bank account has a deposit method. And checking account, does it have a deposit method?
I think so.
Does checking account have a deposit method?
Yeah.
It's right here, right?
Method,
It's
yeah.
the very method that we are trying to write. Which of the two is it going to call when we call deposit?
The checking.
It is unfortunately going to call the checking one because it is a checking account and it always calls the methods of its own class. So if you call deposit in a checking account, it'll call the checking account's deposit. So let's try it. So we're going to deposit $1,000. We increment the transaction count. It's now 1. We're going to call deposit to deposit $1,000. That's going to call itself. The transaction count goes up to 2. It's going to deposit to itself. That's this method. Transaction count is now 3. It's going to deposit to itself. Transaction count is 4, 5, 6. It's going to call itself over and over again. When will it stop? When the universe has died the heat death, right? When all radiation has dissipated. No, it'll call itself when an internal data structure called the runtime stack overflows. And then you'll get what's called a stack overflow error. You'll see if you do that wrong what happens. So it's an easy error to make, and there is a fix, and the fix involves some new syntax. That's on the next slide. You have to say, don't call yourself, knucklehead, call the thing in the superclass. And so the syntax for that is that magic keyword super here. Super says, call this method in the superclass. Same method, but as it's defined in the superclass. And that's very common in inheritance, that you modify the behavior of some method. You say, this deposit method needs to do a little bit of extra stuff, and then it needs to do what the superclass needs to do. So it's very common that you have a method do something.
So could you use super, like the general whatever, like if it were then inheritance class, super would work?
It's always super. Whenever you make some method do something, you would do some extra stuff, and then you would call super do something. Yeah. So super is this magic keyword that says the method that you're about to call, I want you to not call the same method, but to call the one in the superclass. It's something we didn't need until this point, but now we do need it to do this kind of extension. All right. And so let's leave it at this point so that it can sink in a little bit. Let's move on to the lab, and then I'll go over it one more time in the afternoon. So in the lab, we're going to go into Part D, inheritance, because we want to practice that stuff. And so there's going to be a project in here that makes a clock. I'll just let you run it, and you'll see when you draw it, it makes a clock. And so then I want you to modify the clock. When you do that, you don't have to understand particularly how the clock is implemented. The beauty of inheritance is it's a way of extending a class that someone else wrote without having to understand all the aspects of it. So you'll see in Paint component, in the draw method, you'll see some horrible way on how it draws all of the things. You might see some sines and cosines in there. At this point, you'll just completely ignore all of this code. You're not going to have to monkey with that code. You're extending this class. You're just making it a little bit smarter. You're not, and for that, you don't have to understand all of it. So what we do want to do is we want to make the clock so that it changes its background so that it's yellow during the day and blue at night. And so otherwise, all the rest of the clock you want to draw the same way. And so let's just get going. So you should be able to get to the first few steps here. And I'm kind of hoping that everyone gets to step 4 by lunchtime, where super is going to come in. So let's just get going with that.